So we've been doing a lot with factoring quadratics and quadratic equations lately, but finally we're going to take a look at what these things look like on a graph. So you might already know what the basic shape of a quadratic function is, and if not, you've probably seen it before at least. So y equals x squared. Very basic function. Let's see what it looks like on a graph. So let's start with x equals 0. So we're going to be right on the y-axis here. Then y will equal 0 squared. So we have x is 0, y is 0. That's right on the origin. 0, 0. If x is 1, we'll have y equals 1 squared. So 1, comma 1. If x is 2, y will be 2 squared, which is 4. So 2, comma 4. If x is 3, y is 3 squared. That is 9. So you can see that the shape here is a curve going upward like this, getting steeper and steeper and steeper, and continuing on forever. Now what if we go into the negative axis? Well, if we have x equals negative 1, y will be negative 1 squared, which is positive 1. So if x is negative 1, y is positive 1, because whenever we square a negative number, it goes back to positive. Negative 1 squared is the same as 1 squared. So negative 2 squared will also be positive 4, just like positive 2 squared. And likewise, 3 squared will be the same as negative 3 squared. It will be positive 9. So now we have the same curve, but going in the other direction like that. And this is the shape of any quadratic function. It is this bowl shape, which is called a parabola. So no matter how complicated the function is going to be, if it's quadratic, meaning the highest degree term, the highest exponent is 2, it's going to just be a simple parabola bowl shape like that. Okay, let's take a look at another one. Y equals x minus 2 squared. So what we want to find here is our starting point is going to be on the x-axis where y equals 0. So we want to find where does y equal 0. Well, y is going to equal 0 if we make this whole term x minus 2 squared equal to 0, obviously, since that's everything on the other side. And in order to make that happen, the x minus 2 inside the squared needs to be 0, because 0 squared will be 0. So to make x minus 2 equal to 0, x is going to be positive 2. So if x is positive 2, we have 2 minus 2 squared, which is going to be 0 squared, and that is y equals 0. So that's the starting point of this graph. Now let's just do the same thing we did here. We'll increase x by 1. If x is 3, we'll have 3 minus 2 squared, y equals 1 squared, which is 1. If x equals 4, we'll have y equals 2 squared, which is 4. And you can see this is going to be the exact same as this graph, except it's shifted over by 2. So if x equals 5, that's the same as x being equal to 3 here. 3 squared is going to be 9. And it's the same in the other direction. We can just reflect over this curve exactly as it is in the other direction. Just trace these points over without even having to do them again. Just like that. We just traced all of these points over, going 1 over 1x at a time. So now if you notice here, there's a bit of a pattern with the y values. Let's go back to this function for a second. Where x equals 1, we have y is 1. 1 squared is 1. Where x equals 2, we have y equals 2 squared of 4. Where x equals 3, we have y equals 3 squared of 9. And now what I want to do, and this is something that's not often taught, I think, but it's very useful, is look at the difference between these y values. The difference between 1 and 4 is 3. We add 3 to get from 1 to 4. The difference between 4 and 9 is 5. Actually, let's start even before. This is 1 squared, 2 squared, 3 squared. Let's go to 0 squared, where x equals 0. Y equals 0 squared of 0. So to get from 0 to 1, it's plus 1. Do you see a pattern here? Plus 1, plus 3, plus 5. What do you think the next one's going to be? It's going to be plus 7. And indeed, 0 squared, 1 squared, 2 squared, 3 squared, 4 squared is indeed 16, which is 7 more than 9. So what does this mean? Well, it means when you're plotting points on the parabola, as long as you just have this basic vertex form, which means there's nothing in front of the x here, then the y value increases by 2 more than it did the previous time. So what I mean by that is here the y value increased by 1. Here it increased by 2 more than 1, increased by 3. And then we go over once more, it increased by 2 more than 3. It increases by 5, just like we showed here. And that's because when we look at these perfect squares, each one increases by 2 more than the previous one. So this makes it really easy to plot points without having to keep plugging back into the function, because it actually always follows that pattern, because we're always using perfect squares, because quadratic means we're always using squared. So now watch how easy we can graph something like this, x plus 4 squared. The first thing we do is figure out how to get y equal to 0. That's going to be to make x plus 4 equal to 0, which means x is going to be negative 4. So we start at negative 4 on the x-axis. And now look, instead of having to worry about plugging in x equals negative 3, negative 2, and then going the other direction, we can just say go over one x at a time. First we go up by 1, then we go up by 2 more than 1, which is 3. So we're going to go up 1, 2, 3. Then we go up by 2 more than 3, which is 5. So 1, 2, 3, 4, 5. There we go. That's one side of the parabola. And then we just reflect everything over to the other side. So when we go left, we go up 1, go left again, go up 3, go left again, go up 5, just like that. So no need to make an XY table like you may have seen for these graphs. Okay, now we're going to add one more thing to these graphs. You might have noticed by now these are actually turning out to be very similar, at least in the way we do them, to absolute value linear functions, especially when you see something like this. So here we're not starting on the x-axis. We're starting where we're going to make this whole squared term 0. That's what we always do. But when we do that, we'll be starting at y equals 3 because we have this plus 3 sitting on the outside. So we're starting at y equals 3 somewhere over here. Now, in order to make y equal to 3, this whole thing needs to be 0, which means we'll make x equal to 1, because then we'll have 0 squared plus 3, and y will be equal to 3. So x starts at 1, and y starts at 3. That's going to be right here. And once again, we just do our easy little pattern. First, we go up by 1. Then we go up by 2 more than 1, which is 3. And looks like we're going to run out of room to go up by 5 after that. So we'll go up by 1. We go up by 3. And that's going to be good enough here. We're not going to graph as much of the parabola, but that's fine. Okay, so a couple of things I just want to point out here before we move on in terms of terminology. Now, I'm not big on memorizing a lot of terms and the names of things, but this is important. This first point we plotted here on the graph, the point where the two ends of the parabola branch out of, this starting point right here, is called the vertex. And you see the point of the vertex is 1, 3. Now notice here in this form of x minus something squared plus 3, we do have 1 and 3. So we can write a general equation for this vertex form of the quadratic function. So we're calling it the vertex form because it very easily shows us what the vertex is. X minus b squared plus c. And I'm just using b and c as variables for now. You might see why I didn't use a later. But anyway, so using this form, the vertex is b comma c. As you can see right here, the vertex is 1, 3. So 1 is b and 3 is c. Notice again that it's minus b. So we have x minus 1. The x value of the vertex is not negative 1. It's positive 1 because the b only includes the 1. It matches up perfectly. X minus b. X minus 1. So b is 1. Another thing that you'll often hear with parabolas is called the axis of symmetry. And what this basically is it's a line going through the parabola that defines the symmetry of the graph. Symmetry just means that you can reflect it over the other side and get the same thing. So the axis of symmetry for this graph would look something like that. Goes right through the center of the graph, and we can see that the curve is the same on both sides. In other words, it's symmetrical. Both sides are symmetrical. So we call this the axis of symmetry, and it's just a vertical line. So here we can see that that vertical line is x equals 1, which, if you notice, is the x-coordinate of the vertex. And that is because, as you can clearly see on this graph, the axis of symmetry goes right through the vertex, so it has the same x value. So the axis of symmetry is x equals b. X equals the x-coordinate of the vertex, and you can very easily see that from the graph. So those are just some things to keep in mind, and we've already been using that when we reflect points over. What we're really doing is reflecting over this axis of symmetry. But we don't really need to draw that in when we're graphing because it's very easy to just move over one x value at a time like we did. Okay, so now we're gonna be done with that form. We're still gonna be using that form, but we're gonna be starting in a different form now. We're starting in the standard form of the quadratic equation, which is y equals ax squared plus bx plus c. That's where we started for factoring, completing the square, quadratic formula, all that stuff. So how do we graph if we're starting in this form? Well, what we have to do is get it into the vertex form, this x minus b squared plus c, so that we can find the vertex and graph it from there. So how do we get into this vertex form? Well, if you'll notice here we have x squared. Well, let me just write out the formula. See if this good old formula looks familiar. So that is the form of this. This standard form is a squared plus or minus 2ab plus b squared, and we want to change it into the vertex form, which is going to be a plus or minus b squared. So what is that? To get it from this form to that form, that is completing the square. So what we're going to do to x squared minus 12x plus 29 is complete the square. So what we do is we take this, to get from a squared to a, we take the square root of x squared, that's x. And we have a minus here, so we're going to have a minus here. If negative 12x is 2ab, then b is just going to be, we divide out the x and then divide the 12 by 2. So we get x minus 6 squared. then this will become x squared minus 12x plus 36. We added in the 36. That wasn't in the original problem, so we take that out. And then we have this plus 29 still sitting there. Then just do this addition right here. We get x squared, we get x minus 6 squared minus 7. Now we are in this vertex form of x minus b squared plus c. So the vertex b is 6 and c, because c was plus c, when we have negative, c includes the negative. It's negative 7. So the vertex is 6 comma negative 7. So we're going to plot that point to start with on the graph. 6 and then down by 7. So we're starting right there. Okay. And that was the hard part, was finding the vertex. Now it's easy. We just do the exact same thing we did before. We go up by 1, then up by 3, then up by 5, until we run out of room on this graph. So we go up by 1, then up by 3, then up by 5, then up by 7, and then we just do the same on the other side. If you want, you can draw in your axis of symmetry. That's the vertical line going right through the vertex here, if that helps you reflect over that line. But if we start from the bottom, it's pretty easy to just reflect over like this, because you're only moving over one x value at a time, and the y values are the exact same on the other side of the parabola. There we go. That one's done. Okay, what if we have something like this, x squared plus 6x? There's no constant term here. There's no number out here. Well, we can still use completing the square, because let's look at the completing the square over here. Remember, we use the a squared plus 2ab to convert to a plus b squared. We just ignore this b squared term right here. We just ignored the 29 and then tacked it on later. So the only difference with this, when we do completing the square, is we won't have anything out here to tack on later after we've done completing the square. This transition, we won't have a plus 29 to tack on like we did here. But we're still doing y equals x plus, so it's a plus here, plus half of 6 plus 3 squared. And then this becomes x squared plus 6x plus 9. We don't want the plus 9 in there since it wasn't in the original problem. So we take out minus 9 to cancel out the plus 9. And there's nothing left over here. So we're done. This is the vertex form. The vertex of this graph is going to be negative 3, negative 9. Why negative 3? Because in the vertex form, it's x minus b squared. So when we have a plus 3, then plus is the same as x minus negative b. So it's the opposite sign of whatever's in here. If it's plus 3, the x-coordinate of the vertex is negative 3. Okay, so this is the vertex. That's where we start. Negative 3, negative 9. And you know the drill from here. Up 1, up 3, up 5, up 7, there we go. And exact same on the other side. Always moving over by 1x. Okay. All right, couple more. So your first thought with this one might be, how do I do completing the square when there's no x term here? Because we just have x squared and a negative 2 for a constant. Well, the answer is you can't, because the x term is required for the completing the square method. So think about this in terms of the very first problem that we did. Let's go back to that for a second. Y equals x squared. This is the exact same thing, but with a minus 2 on the outside. So we literally take the first graph we did, and we shift it down by 2, because now we're starting at where y is negative 2. Right here. So we take the standard x squared graph right there, and we just shifted the whole thing down by 2. And from here, once again, up 1, up 3, up 5, and the same on the other side. Now, if you wanted to write this in vertex form, it wouldn't technically be completing the square since there's really nothing here to do. But if you just wanted to put it in this form, x minus b squared plus c to confirm, you could write y equals x minus 0 squared minus 2. I just changed x to x minus 0, which really is the exact same thing. But this indeed proves that the vertex is 0, negative 2. Because we have the 0 from here. The opposite of negative 0 is positive 0. Again, this is really kind of silly because they're both the exact same thing. And then the negative 2 of c becomes negative 2 here. But anyway, you should just recognize from this form here, we just have x squared by itself, plus or minus a number, that you just take the standard x squared graph and just shift it up or down by the amount that y is changing from the start. Okay. We're going to do one more in a different form. The last form that we're going to be looking at. We're going to be starting in a factored form with this graph. So how do we get to vertex form from here? Well, first we have to put it back in standard form, which means simplify this out. So this is where all of the simplifying and factoring and completing the square, it all comes together now when we graph. So now we're going to be simplifying back out. So we're going to get x times x is x squared minus x plus 3x, that's plus 2x. 3 times negative 1 is minus 3. So now that we're back in standard form, now we can complete the square and go to vertex form. So we take x plus half of 2 is 1 squared minus, let's see, we added what, x squared plus 2x plus 1 we have here, this 1 squared. We'll take out that, so we put in a minus 1, and then we bring down the minus 3. So we end up with y equals x plus 1 squared minus 4. And the vertex is not the positive one here, it's the x is the opposite, so it's negative 1, and the y is the same sign, so it's negative 1, negative 4. Plot that point on the graph, and then you know what to do from here. Up 1, up 3, up 5, and there's no room for an up 7, so we'll just leave it like that. Okay, we are going to stop there, but there is a ton more to do with graphing, and that is just in this vertex form before we even take a look at how to graph using other forms, which is also quite possible. But hopefully what you're seeing here with graphing is that everything we've been doing in the past couple units, whether it's factoring, completing the square, simplifying, all of that stuff is all coming together here. So if you feel that you are a little bit weak in any of those areas, I would definitely recommend you do some more practice before you continue on with graphing, because we're going to be using even more of those skills in the next few videos.